Welcome everyone to Parametrics and Formula Control. We're going to be looking at parametric drawings in AutoCAD. So what are parametrics? Should you be interested in using constraints? So basically with a parametric drawing, we're able to create constraints in our drawing and make things work. So if you've ever wanted to keep multiple lines parallel, perpendicular, or any other situation after editing one line, or to keep multiple lines the same length when one is edited, or maintain relationships between objects during editing. If you answered yes to any of those, parametric controls may be the way to go forward with your drawing. So with parametric constraints, they're objects or information that's added to objects in our drawing. The Autodesk definition is it's a feature in AutoCAD that assigns constraints to objects, establishing the distance, location, and orientation of objects with respect to other objects. Examples of this, when we're working with AutoCAD, we can snap to objects in our drawing, so endpoints, midpoints, and things like that. When we're using constraints, we have things called sticky object snaps. So if you've set a snap to be perpendicular in parametrics, they will stay as perpendicular. You won't have to reset the O snaps or anything like that. Those object snaps will be remembered. It also allows objects to relate to others. So we might have ends of lines that we want to be coincident with each other. We can make those points stay in contact with each other. We can also have dimensions placed in there, and they can drive the geometry. So if you modify a dimension, you can make the object expand or contract based on the dimension that you apply to it. The associations and restrictions are applied to 2D geometry only when it comes to parametrics in AutoCAD. AutoCAD uses two types of parametric constraints. There's geometric constraints. So the geometric constraints will be the intersections, the endpoints, those sort of situations, and dimensional constraints, which are similar to dimensions, but will give control over the lengths of things. We've got an example over on the right-hand side here. We've got some dimensional constraints in here, and we've got a formula that's been placed in here, and we've got these controls in here. When we have a constrained drawing, we can see that we have an auto constrain or a constrained icon that appears on screen. We're going to have a look at geometric constraints and dimensional constraints during this session. On the ribbon, the Autodesk definition rules that define the geometric relationships of objects or points of objects, elements, and control how an object can change shape or size. As I stated, there's sticky object snaps. So when we're using the coincident, it'll ensure that the endpoints touch each other. And it will also add intelligence to your drawing. You'll notice on the ribbon that there is a geometric tab, a dimensional tab, and a manage tab. The geometric tools are all located within the geometric tab. And on the right-hand side, I've got an explanation of what each of those are. When we're adding constraints to our drawing, we can make AutoCAD automatically constrain the object, or we can get it to infer constraints. When we do an auto constrain, it applies geometric constraints to the selection set that you've created within a specified tolerance set. So that'll be based upon the constraint settings that you have in here. Using the constraint tab, it uses auto constraint tab in the constraint settings dialog box. Infer constraints, when we're drafting, when we're drawing lines and things like that, it can actually infer constraints. So if you draw lines that touch each other, it will infer those constraints. We will have a demonstration of this section in just one moment. Similar to the AutoConstrain command, constraints are applied only if the objects meet the constraint conditions. So that's the settings that we have for the AutoConstrain settings. Objects are not repositioned as a result of inferring constraints. So we might just duck over to AutoCAD and we'll just have a look at a couple of these items in here. So with AutoCAD, when we draw lines, line, you'll see that when we grab this line here, we're able to move this away. When we're working with AutoCAD, we can also turn on the infer constraints down here. And if I do that same thing again, line, click and click, you'll see that there's been a little grip that's been placed on the end here. And if I hover over here, we can see the infer constraints button. If I click on this line here, grab this grip and move this around, you'll see that it's going to keep that connection with the line. Okay, so that's going through into a connection between objects. If you were using a polyline, the polyline would get that connection happening by default, but with the two lines, we're able to manage that situation here. So based on that, I'm just going to draw some lines. I'm going to turn off infer constraints. Just going to draw a line, another line, and another line. So here, we can auto constrain, select the objects, and we'll see that nothing happens. Or sorry, it does happen. It's keeping these objects perpendicular to each other because it's found that they are perpendicular. When I move this one around, so if I rotate, you'll see that the other line will rotate and keep that perpendicular distance or that perpendicular angle. If I go down here, you'll see that it will just maintain that perpendicular orientation. If I turn on auto constrain, and we might just draw a rectangle. Sorry, I'm going to infer constraints. I'm going to draw a rectangle. And you'll see here that it's actually applied constraints to our drawing. You'll see here it's applied a parallel constraint, and the complementary parallel constraint is applied to this one over here, this line. You'll see the vertical lines here. We've got a parallel constraint, and we've also got a parallel constraint here. So these two lines are parallel with each other and will remain parallel. It's also assigned a perpendicular up here. So this corner here will always be perpendicular. If I click on here, single left click, grab a grip, move this in, you'll see that the objects will change shape as expected. If I had a normal rectangle, so this is a constrained rectangle. If I grab that grip, that will move around. If I grab this same grip here, you'll see that there is no control over the objects. We're able to move them around. If I was to remove the perpendicular here, if I right click on here, I have a delete option. If I hover over here and click the X here, that will only hide the constraint. It will not delete it, it will stay. So if I right click here and go delete, we've got parallel for these two lines, these two vertical lines, and we've got parallel and parallel here. If I now grab a grip and I drag, if I grab a grip, you can see that now we've lost the perpendicular grip or the perpendicular maintenance. Okay, so just a little one there. We're just going to head back to the PowerPoint now. With geometric constraints, the constraints are applied between two entities and modifies the second deleted entity. We will revisit the constraints at the end of the session. I just wanted to quickly go through that one whilst we were here. The edit behaviors, when you change an object, such as exploding a polyline, the constraints will be deleted from that object because the polyline will no longer exist. It will return to lines and arcs, and there were no parametrics assigned to that object, only the polyline. Copying an object with constraints. If you copy all the objects that are constrained, all the constraints will be copied. If you only copy part of an object and there are constraints that are applicable, they will be copied through to the copied versions. Dimensional constraints. You can see here that we have an area on the ribbon called dimensional. The Autodesk definition of dimensional constraints are parametric dimensions that control the size, angle, or position of geometry relative to the drawing or other objects. When dimensions are changed, the object resizes. So we can enter a dimensional constraint. We've got different types. I've outlined the different types over here. So we've got linear, horizontal, vertical, and so on. We can assign dimensions or dimensional constraints to our object. Entering a value into a dimensional constraint will update that object. If there are formulas associated with other objects that may reference that, those formulas will be calculated and those objects will be reduced or enlarged in accordance to the equation that has been set. You're also able to reference other objects. So as I stated with the equations, we can reference other equations in the drawing that are assigned to objects, and we can refer to those and bring that information through to our current dimension. With the ribbon as well, you'll notice that on the previous one, we've got geometric, which was this area here, and we've got dimensional here. Both of the tabs have a show all, hide all, and show hide option. So we will look at that when we get into the drawing, and we will have a look at the implications of those items as well. There are two different types of dimensional constraints. There's dynamic and there's annotational. Dynamic Dynamic, when we're zooming in and out of the drawing, they will remain the same size regardless of the zoom. They can be turned on or off globally in the drawing. So that was the on-off that we saw in the last slide. Display using a fixed predefined dimension style. So we have no control over the dynamic display of the dimensions. It will position textual information automatically, and these dynamic dimensional constraints do not plot. They can be converted to annotational constraints using the properties palette. So they can be converted into dimensions that can be plotted. If you're using annotational dimensional constraints, they will change their size when zooming in and out. Similar to when we have annotation assigned to an object, when we change our drawing scale, the scale will change and will be associated with the dimension that is associated. It will also change the size when you're zooming in and out. You will have control over the layers that the annotational dimensions are placed on, and they will display using the current dimension style. You'll also see grips on the dimensions, so you'll be able to move the text around. You'll be able to reposition the line work to do with or related to the dimensions. These annotational constraints will also plot on your drawing. You can choose between having dynamic and annotational, and there can be a combination within your drawing. You might only have a single dimension that you want to plot, and that can be set to annotational. The formulas that are associated with these annotational dimensions will also be updated if we modify any of the other dimensions that are associated. And you can convert them back into dynamic constraints so they do not plot. when we're working with dimensional constraints, we can place equations or have equations placed into our dimensions. We've got normal operators. So we've got our normal addition. So on the left-hand side, we've got the operators used in the expressions. We've got the normal sort of things like addition, multiplication, division, and a few other options in there. And then we've got functions that are supported in expressions as well. So you can use the cosine, so cos, and then whatever the expression is. This panel here just displays the different options that are available when we are adding constraints and expressions into our drawing. You can also use the constants pi as well, so there's no need to do the 3-point whatever, for calculations and things like that. So if you're working with arcs and radii and things like that, you can use pi in your calculations. Some dimensional constraint tips. When you're applying dimensional constraints, it modifies the constrained geometry to satisfy the applied constraint, if the constraint is valid, that is. Converting an object with constraints to a polyline removes the applied constraints, so similar to the other constraints. If you explode, those constraints will disappear. Copying an object with dimensional constraints will copy the applied constraints. So if you copy the objects that are constrained and those constraints are still valid when you copy them, they will be copied. If they become invalid with the copy, they will be removed from the copy. Dimensional constraints can contain equations. So based on that last page here that we just looked at, we can bring these equations into our dimensional constraints. Having said that, we're just going to have a look at AutoCAD now. So we're just going to return in here. I'll just erase these two objects here. Are there any questions, Shane, before I move on to the practical demonstration?
So there have been some questions which I've answered directly, which a question about using constraints in blocks, which is actually a topic for another session. One that I might actually flip to and show. There was a question about not seeing the parametric tab in Civil 3D. So given that we've got some Civil 3D customers on the line, I might just steal the podium from you and show that to customers.
Go for it.
I'll just poke over it and show that now. So in Civil 3D natively, you will not see the Parametrics tab, and this is a consolidation by Autodesk to focus on the civil engineering side. But if you look at the little panel up the top, there's a drop down here where you can.
I don't think you're sharing, Shane.
Oh, we're not. It does.
I've just shared my auto. I've just started up Civil 3D on my PC.
Okay. All right. It does say that I am sharing. Can we have a show of hands from anybody who can see Civil 3D right now? It might be Selwyn, you're just not seeing it. I think everyone can see it. So,
okay.
From the top panel, you can turn on the display of workspaces. And workspaces is an opportunity to arrange the ribbon the way you want. What commands you want to see, what tabs, what panels. But critically, if you flip from Civil 3D to drafting and annotation workspace emulates the standard AutoCAD ribbon interface, and that interface includes parametrics. So if you are not seeing parametrics, just flip your workspace and then you'll see the parametric panel up. So that answers really the key questions that were coming up. So if you want to steal the podium back, I'll stop my share, but maybe you just steal the share directly from me.
Sure. Sorry, I've just got it. Okay, I think I'm
You're
back.
back.
Yep, beautiful. Okay, so with our constraints, we're looking at parametric drawing. We're not looking at parametric blocks. So just be aware of this. Parametric blocks will be at my next session in a few weeks. Shane will fill you in about that one at the end of the session. So the drafting that we're doing here is related to our just parametric drawing. So having said that, we're just going to have a bit of a play around. I'm just going to draw a rectangle. I'm going to leave infer constraints off. And I'm just going to do a rectangle. I'm just going to go 1000 by 1000. Okay, so we've just got a rectangle here. We want this rectangle to be constrained. The easiest way would be to go auto constrain and then choose the object and go around, and it will automatically constrain the rectangle. I'm not going to do that in this situation. I'm going to explode this. So now we've got lines. Okay. So what we're going to do up here, we're going to go to the geometric panel, this one here. Before we do that, we're just going to have a look at the settings. So same with the other tabs on our ribbon, these buttons here will bring up settings. So we've got settings here and we've also got settings here. If I click on the geometric settings here, it will bring up the constraint settings and it will display the geometric tab. If I click on this one here, it will bring up the dimensional tab. On the geometric tab, we can choose the constraints. If we were to have infer constraints turned on, it would apply these constraints to our objects. So you might have only certain ones that you want to work depending upon the criteria that you have in your drawing. You can also change the transparency of the constraint bar. So that's the little icons that show at the corners or wherever it may be in our drawing. And we've also got the show constraint bars after applying constraints and constraint bars when objects are selected. So it's going to display the constraints. I'm going to turn off infer constraints here, and I'm going to manually constrain this drawing. I'm going to come up here to coincident, and on each corner, you'll see when I'm near a corner, it's got a little glyph that shows on screen, which is red. If I go along the line, it will snap to the midpoint. You'll notice that when we are adding constraints in AutoCAD, let's do an arc, just for an example. When we, actually, I should be able to pick that. So you'll see that we can snap to the endpoint, we can snap to the midpoint and the endpoint. So there are certain snaps that are available in our constraints. So just be aware that there's no near, but it's mainly mid, end, and there's a few other O snaps that work in here. So to start with, we're going to go coincident. So we're going to go near the end of the line, just so we have that grip showing there, or that glyph. Not to the middle, because if I go to the middle and then click on this line, you'll see that this line will now be coincident with the horizontal line. So if I move that around, it will always stay in the midpoint of that line. I'll just undo that, get rid of that one. You will also notice that when I selected the objects, when I selected this one here, and then this second one, the second object moves. So just be aware that when you're creating your constraints, the sequence that you select is important. So I'm going to go constrain to the coincident point here and coincident here. So that will put a little grip on the corner here. I'll just hit enter and repeat that again, enter and repeat that again. Just so we now have, if I was to move this around, you can see that it's now connected to the other objects. So it will always stay coincidental at the corners. Okay, we might want, for whatever reason, the bottom line to be always horizontal. So over here, we've got horizontal. I'm going to pick on this line here, and we've just added a horizontal constraint. So when I try and move this line here, you'll see that that line will always stay horizontal. Just going to escape out of that. So we want this to stay in with parallel lines, both horizontally and vertically. To do so, we're just going to go to the parallel geometric constraint, click on parallel. We'll pick the first line and then the second line. So those two will be constrained. You'll see that we now have the bar, and that grayness or whatever is based on the setting that we have here for transparency. So if I take that back to 0, you'll see that they fade out. Let's take that back to 50 or thereabouts, just so they stay on screen, just so you guys can see what's going on. I'm going to go parallel once more, and we're going to pick the vertical lines. So now, when we move anything around, objects will stay parallel. If I try and rotate, I'm unable to do that because I have the horizontal constraint, this one here, associated. Because I'm trying to rotate, it's asking me to relax the constraints. So if I go relax constraints, you'll see that it's actually removed the constraints applicable to that object I was trying to rotate. If I undo, I'm going to go rotate again, and I'm going to select the entire, so rotate and select the entire thing. Relax constraints, and now you'll see that we've maintained the parallel constraints. So when we move things around, we still have the parallel constraint. Okay, so we might just set that back to horizontal. And you'll see that now we've set those lines horizontal. We don't want a parallelogram, we want it to be rectangular. So what we're going to do is we're going to click on the perpendicular constraint here. We're going to click on the first entry and then the second entry, and then that will make that into a rectangle again. It's actually a square at the moment because it's got 1000 by 1000. So here we have the geometric tab. We've got hide all. If we click on hide all, it will hide those constraints. If we click on show all, it will show all those constraints. If we click in here and click on the X, those constraints are still there, but they are invisible. If we go show all, they will reappear. So you might want to turn them off if you want to select something on screen, so you can have them all on or all off. If I do a preview of my drawing, you'll see that the constraints do not appear at all. Okay. So we're just going to go across and we're going to add some linear constraints to this drawing now. We're going to go linear. Same as with your normal dimensioning. So if you're going to dimension, press enter, you can pick your points and it will allow you to dimension. So in here, we're going to go linear dimension. I'm going to pick a start point and an end point, and we'll place that up here. You'll see that it states D equals 1000. If I click out here, it still states D equals 1000. When we zoom in and out, you can see that the text will stay the same size. And we have the name of the parameter. which is D1, and that equals 1000. We're going to now add another dimension. We'll go linear once again. This time I'm going to press enter, and I'm just going to choose the line just so it picks that line. And now it's going to be D2 equals 1000. So what we're going to do, we might just click here, double click in here. We'll change D1 to horizontal, and we'll change D2 to vertical. So we can have names for our functions in here, or our parameters. If we have a look at the parameters manager here, go on here, you can see that we have dimensional constraints, we've got horizontal, and we've got vertical listed in here. Both of these are stated as 1000. So in a simple situation, if we come in here and we change that to 500, you'll see that the horizontal lines, I'll just zoom out a bit, will change to 500, and the vertical will stay at 1000. In here, if I double click on here, maybe we want the vertical to be the same as horizontal. So we could go vertical equals horizontal. So now, if we change this dimension here, I'll go 525. You'll see that the value changes. Sorry, I did 526 by accident. You'll see here the value is stated as 526, and the horizontal dimension is stated as 526. So you see that this one is linked to this dimension here. I'm going to set this back to 1000. And we're going to do a basic calculation in here. So we might want the horizontal to be 1000, but we want the vertical one to be half that length. So if we go vertical equals horizontal divided by 2, you'll now see, once I click out here and close that the vertical is now half the length of the horizontal distance. So over here, horizontal, we have a real number that's been stated. Vertical is being calculated by using horizontal divided by 2. You will also notice on the dimensional tab, we've got hide all and we've got show all. So same as with the geometric constraints, we can turn them, we can hide them, or we can turn them off. We've also got grips in here, so we can modify that, and you will see that the object is scaling up or down, whichever way we go, and the vertical is at half the length of the horizontal. So having said that, we've got control over this rectangle. We might want to put a circle in this rectangle. I'm going to put a circle. I'm not concerned about the size or anything like that, but we want that circle to always be in the middle. We'll go center, and we'll go shift right click mid between 2 points, that point and that point. We want it to always stay here. At the moment, if we were to move or change the, we might just go for the grip up here. I manually place that item in here and it will stay where it is. So what we want to do, we want to make it stay in the middle of our rectangle. To do so, we're going to go linear again. We're going to go from this point to the center, and we might go horizontal. And D1, so maybe we'll go half, we'll go horizontal half. So this might be, we might use horizontal. So we've got the horizontal distance, and we'll divide that by 2. So that will move it over into halfway along the horizontal line. We're now going to do another linear one. We'll choose that endpoint. We'll choose the circle again. We're going to come out here to the left. And this one will go the half equals, we'll go vertical divided by 2. So here, we've halved this dimension to get this location here. This one here, we've halved this dimension to get this location here. So now, when we move this around, let's change, you'll see that it moves around. If we grab the grip, move this in, you'll see that the vertical distances are halving and the horizontal ones are repositioning the circle where we want. If we keep going, it's going to keep going, and that circle is going to be in here now because we've gone so small. We might find it's going to come out larger again. So you'll notice that I'm using the grip. I'm not concerned about any dimensions. So all the dimensions are linked to this single dimension here. What we want to do now is we want to maybe force the circle to be a certain size. So here we're going to come up to the radial dimension. I'm going to click on the circle, so on that side, and we're going to click. We'll go inner equals, maybe we go vertical divided by 2, and that will make the radius the full width of the object. So when we move our grips around or anything like that, you'll now find that that circle will scale up or down based on the scaling and will stay where it is. Just escape, sorry, regen. That's the size of it. So here we have our objects in here. So when we're changing our scale, you'll see that we don't have any grips on this one here. The only dimension that we have grips on is this one here, because this is the only one that has a real dimension assigned to it. So anything that we put in here will control the size of our drawing. So if we go back to 1000 and we check on here, we've got 1000 across here. If we have a look at the distance down here, that should be 500. And the radius will be 250, and that's where it's positioned. We might want to have another circle. So maybe another circle, just put a circle in here. We want it to be in the same location as this one here. So the center point will be in the same location. So to do so, we're going to click on concentric. I'm going to pick the first one, then the second object. Sorry, I went the wrong way. You'll notice that the object moved because I chose incorrectly with my sequence. I should have chosen the circle first and then the object to associate it with. So you'll now see that this circle is in the middle of this one here. If we come back in here, you'll see that that inner circle we just created will always stay that same size, no matter how large we make the window. So we might want that middle circle to change its size based on the circumference, or sorry, the radius of the outer dimension. So we're going to go radius again. We'll click on this one here. Let's go to the left. Should have gone, I've got it in reverse. Change that in a moment. Inner one equals inner divided by 0.75. Went wrong there. Multiplied by 0.75. So it will be 0.75 smaller than that outer circle at all times. I've got an issue with my naming, so I'm just going to come over here. I'm going to rename this one to outer. And you'll notice that when I change this one to outer, the calculation here became outer as well. Okay, so there's a link between the formula names that we have in our drawing. When we print this drawing, so I'm going to go Control P. I'm going to go a window around here. And I'm just going to go preview. And you'll see that none of the constraints that we have on screen will appear. I'll close that window. So with constraints, these do not appear on screen. We can hide them all. And we can see this drawing. When we click on Show All here, we've got our dimensions in here. And they're stating horizontal equals whatever it may be. We can click on a dimension, and on the Properties window, under Constraint Form, there is a drop-down, and we have Dynamic or Annotational. If I go Annotational, it's now going to pick up my dimension style. Put that back into the middle. It's going to pick up my dimension style that's been associated, or my default dimension style. If I click on this, you'll see now it's a rotated dimension. The constraint, annotational. If we expand this one here, we can change it back to dynamic if we want. Okay, so we can toggle between either or. So with this one here, if I do a preview again, you can see that that dimension appears on screen. The issue with the dimension that you can see on screen is it may not state what you want it to state. So with this one here, if I turn that into a annotational dimension, I'll put that back in the middle, thereabouts. When we do a preview, it states the entry that we have. To resolve that issue, we'll come up here to the settings window up here. And under dimensional, we've got the dimension name format. I would recommend leaving it to name and expression whilst you're setting up your drawing. However, when you're coming to the stage of plotting or outputting, there's an option here for value. If we click value, go OK, you'll see that the figures have changed to real, the display changed to the real figures. So if we go preview again, we can see the dimensions appearing on screen. We cannot see the other ones because these ones have not been converted to annotational constraints. If we select these ones here, go dynamic, annotational, and they will be placed in there. So same with this, here, dynamic, annotational. So here, we still have those controls. So we can come in here and we can move that grip, we can stretch. And you'll see that the text is staying scaled as it would be expected with the annotational dimensions. And the dynamic dimensions are staying at the same scale, no matter the zoom level. So these dimensions are based on your dimension style that you have current at the time. You can change the dimension style if you want. However, by default, it will pick up that dimension style. And basically, I think that's a quick run through of parametric drawing. Are there any queries or questions, Shane, that need to be addressed?
Thanks, Owen. Well, look, certainly looked great. It was great to see how to control everything and manage one change, multiple updates. Yeah, there are a series of questions. Some I've answered either by writing back or giving you the time to fill out. So there was one question that if the dimension constraint is set to annotative, can we get rid of the variable? You know,
Yeah,
horizontal equals.
that was
Yeah,
up here with the settings, just setting the value name.
value only. Yeah,
Yeah.
yeah,
So if you did name, it would be whatever the expression is that we've used.
yeah, yeah. So there's a question here asking about whether the variables are case sensitive. So
No,
no,
not case sensitive. No, no.
okay,
You'll notice that with my typing, with the variables that are listed up here, I've got capital VER, I've got lowercase VER, I've got uppercase horizontal, and I've got lowercase horizontal. So case sensitivity doesn't come into it at all when it comes to the parameters.
yeah, great. So there is an interesting question around constraining a block onto, say, a line. So uh, can the insertion point of a block be constrained to match coincident to a line?
That will be covered in parametric block. Sorry, the parametric blocks when we look at those.
Yeah,
When you're working with sorry, I've got to create a block to do that. There's an align. Hold on. I'm just going to do a quick line block. And I'll just go quickly. So I'll just edit this block. On the ribbon that appears here, under parameters, you've got alignment. So when you add an alignment one here, this will actually rotate the block based on when you hover along a arc or something like that, it'll start rotating that block
no,
based
that's
on the
cool. Thank
line.
you. I think the question it might be a bit simpler in that they just want the block position to move when a line moves. So it's just the insertion point of the block.
You can have a, sorry, I'll just go, oops, to bring that one back. So we might have, I'll go coincident, I'll go here and I'll go here. I'm not sure if this is, so you can see it's tied to that block that object at that location. So I associated it with, or made it link to the midpoint of that line. Is that what you're after?
I
I
think that
think.
answers the question. I invite the Colin if that didn't answer the question to reframe it, but I think that answers that question. There was one more which I think I answered, but the question was, can you have multiple objects with the same vertical constraint?
Yes.
My answer was yes, and you just set each constraint to equal the source
Yeah.
constraint.
So if I go back to, I'll set this back to name and expression, just makes it a little bit easier for me to see what's going on. So here, this one, if we set that to horizontal, it will, so vertical equals horizontal. You could have another, so if I get rid of this one here, I'll do a circle. I'll go radial diameter. I know the position isn't going to be right. So if we go diameter equals horizontal, so I'm using that same entry.
Yeah.
So vertical equals horizontal, diameter equals horizontal, horizontal is whatever figure that may be. Okay.
Excellent. No, it's good.
Yep. So
I did get an expansion on that question around, locking a block or any object onto another object. So the details of the question were putting a block on two grid lines. So imagine you had a vertical line and a horizontal line. They're trying to get the block to be at the intersection of those two lines and to stay at the intersection of those two lines. I'm not sure whether that's
yeah. So if you've got the block, just bring that one back. Oh no, that's the wrong one. So if we've got a line, coincident, grab that one and that one. That one through, and I'll go coincident again. So when we move this endpoint, they'll stay on those endpoints.
Yeah, so if you had another line perpendicular to that, they're looking for the crossing over of those two lines.
Okay, so if that's here, that you would need to set a perpendicular.
Right, and the perpendicular would hold that.
Yeah, to keep that perpendicular.
Yeah.
And you probably might want a coincident as well. But it's only going to snap to the midpoint of that line.
Yeah, okay.
So there are limitations there. You might be better looking at the constraints that are available in the block rather than the drafting constraint.
Yeah.
Which will be covered in the parametric blocks session. There's probably more like.
No problem. So I think the answer would be probably to set up the grid and the block based on dimensional constraints. And so the grid lines and the blocks run on dimensional constraints could work.
Maybe.
Yeah.
Yeah, I'm just a little bit unclear of what we're trying to achieve.
Yeah. No, that's cool. I'll just reply to the question on that basis. Cool. Well, I think that answers most of the questions that have come up. There was a question, can you type a number in the dimension and the object sizes resizes to that value? And I think you've shown that, but yeah, it's the information's expressed in a number of places. I think they're asking about whether you can do it from the properties box, but you're doing it, yeah, right there in front of it. Yeah.
I'll just escape out of there. So here, if we select the just trying to find the length. I'm pretty sure you can. I know with the blocks, so there's the expression there. So under constraint. So if I go 1,000,
yeah,
it will scale down. That circle didn't go because I was showing you using the horizontal for each of the constraints.
excellent. Well, thank you, Selwyn. It was a very informative session, some really great practical approaches to using constraints and parametrics. So hopefully everybody got a lot out of it. I certainly learned a hell of a lot more than I knew before about parametrics. So thank you very much from me personally. What I'm going to do is just flip over to our final slides. So I'll just push over the presentation of my screen. So hopefully everybody's seeing the final slide here. Again, thank you for attending the webinar. Thank you so much, Selwyn, for that session.
A pleasure.
If you are interested in the recording, that is the link, YouTube Civil Survey Solutions. And then being all modern, there's a QR code. And we did talk about the idea of expanding the idea of parametrics through into blocks. So if you did see an earlier session, we introduced dynamic blocks in a webinar, again, presented by Selwyn. And what we thought we'd do to round out this triad of webinars is to talk about the idea of what you've seen in terms of parametrics working inside a block. So we'll explore more about edit controls for blocks and dynamics of blocks through parametrics. So that session is set for 10th of July. So if you're available, please register, and we'd love to see you there. So again, thank you very much, Selwyn. Pleasure as always to host such a great webcast. So thank you.
Thanks, Shane. Appreciate it. And thank you, everyone, for attending. I hope you got something out of it.
Thanks, everybody. We'll see you in the next webcast.
Cheers.